Modern Coast Engineering is proud to present to you the proposed county animal shelter located in the city of Santee, California. Our team consists of myself, Bishar Al-Samarai, transportation engineer and civil engineer, our project manager and site civil designer, Rodrigo Nascimento, and Warren Mullah, geotechnical engineer and foundation designer, Daniel Hassawi, stormwater engineer, Hamad Al-Judaimi, structural engineer, and Abdul Aziz Al-Shihab, water and wastewater engineer. Together, we represent Modern Coast Engineering.
The proposed project, we propose developing about a 4-acre portion of this lot and building a 24,000 square foot building for the county animal shelter. The project includes site civil design and drainage study and stormwater studies, water and wastewater studies, geotechnical study with the foundation design, a structural design for the building shell, as well as construction. The site location is in Santee, just off of the 52 and 67 freeways, at the corner of North Magnolia Avenue and Riverview Parkway. In the existing condition, the site is a 10-acre lot, is mostly undeveloped except for a graded pad. There is water and sewer services on Riverview Parkway. One thing that's important is that the San Diego River runs just north of the site, and so that requires special attention to any stormwater runoff towards the river. For site civil design plans, we have two different sets of plans. The grading plan here, it proposes actual minimal earthwork because of the existing graded pad. It shows all the proposed drainage design and proposed wet utilities, as well as permanent stormwater BMPs. It also has an erosion control plan attached to it that shows temporary stormwater BMPs for the construction phase. The improvement plan shows the proposed improvements along the public right-of-way of Riverview Parkway. We're proposing to widen the Riverview Parkway, as you can see with the light and dark shadow on the plan on the screen. It also proposes curb, gutter, and sidewalk, and it shows all the proposed utilities in the public right-of-way.
Moving on to the drainage study. First of all, we're proposing a design storm for a 100-year rainfall event. We also classified our soil type as A. It is very important to meet all the stormwater quality management plan requirements when designing a drainage system. For any drainage study, we need to have both pre-developed and post-developed studies that include the elevation and area for each basin. For the pre-developed drainage, the land use is open space, and for the post-developed, the land use is low-density residential, since we're adding about 20% of impervious value. The total area for both remained the same, which is 12.3. So calculations for the drainage study were conducted, which include the runoff coefficient, time of concentration, intensity of rainfall, and flow rate using the rational method. Therefore, the most important steps in designing a drainage system is to meet all the stormwater quality management plan requirements and conduct all necessary calculations.
For water and wastewater studies, we will be calculating the fire flow, select the fire hydrants, and design sewer pipes. Starting off with the fire flow, the needed fire flow is calculated, and as we have a single-story construction, 2 hours of water flow is needed. To select the fire hydrants, we assume the orifice size and pitot pressure, so water flow is calculated. And based on our result, the color assigned to the hydrant will be blue, and we will use 2 wet barrel hydrants. Regarding the sewer design, we have problems in old pipes, so we need to replace them with new ones. And after calculating the thickness and diameter of the pipes, we will replace the old pipes with 8-inch diameter PVC sewer pipes. Therefore, we know the water flow needed and selected the hydrants and the new pipes for our site.
For the geotechnical study, I will briefly explain the data that was collected, the deterministic hazard analysis, the soil classification chart, and the foundation analysis. Borehole data was obtained using the in-situ test, the cone penetration test, and this data will be assumed as the subsurface of our site. A deterministic hazard analysis was conducted to find the peak ground acceleration, which was then used for the liquefaction analysis. The methodology followed is described in 4 steps and is illustrated in the figure on the right. The USGS website was utilized to find the nearest tree faults to our location. As you can see, this is the CPT summary table that shows a summary of all the parameters found. 5 layers of soil have been identified. A couple of things I would like to point out is that the first layer, which is mixed silty soils, will be excavated. The peak ground acceleration in the last row is 0.27 Gs, and none of the layers were found to be liquefiable. For the foundation of our building, it was decided that it is most efficient to design a deep foundation where the building will be laying over friction piles. It was designed this way because of the close proximity of the building to the San Diego River, and therefore a high-capacity foundation system is desired in this case. Moreover, for foundation design, the water table will be assumed to be at the ground surface, and also calculations of the ultimate bearing capacity in the short term and the long term, as well as the factor of safety, will be found.
And now moving to the structural study of the animal shelter. The structure of the animal shelter will be constructed in the yellow highlighted part of the exhibit, where the total area of the building will be 23,471 square feet. Also, as agreed with the geotechnical engineer, the structure of the building will be designed over friction piles, where there will be a group of floating square piles. For the bottom slab of the animal shelter, the structural calculations suggested that it would be best to design a 4-inch concrete slab with number 4 rebars, which are half-inch diameter rebars at 12-inch spacing, and also number 4 rebars at 7 inches for the strongest slab possible. The overall design of the structure will include some reinforced concrete sections as well as steel structure sections. There will be a total of 26 reinforced concrete columns that will hold the building. For the outer walls of the animal shelter, there will be brick walls with 10-inch thickness, while the inner walls will be 5-inch brick walls, and the roof of the building will consist of a K-type steel truss with steel sections, where the steel sections are bolted to the gusset plate. And this is the overall structural design of our building.
I was in charge of the construction portion of the county animal shelter. A few tasks that I was responsible for: the access and site, the project site layout, the sequencing and testing of work, the drilling and dip plans, the cost estimate, and lastly, the project schedule. The proposed site layout includes all important considerations when the construction began, along with the truck haul cycle. During construction, there will be one line blocked on the west side, and there will be another line blocked when construction starts on the north side. Since the high demand of work will be existing, the need of 2 trucks haul is highly recommended. North side of the project, the truck haul time calculated as 7.61 minutes. For west side, time calculated as 8.61 minutes. The total expected cost of the project, approximately $8.45 million. The estimate obtained from County of San Diego unit of price list, estimate of grading, and various sources from online. Our studies have determined that all proposing improvement and design techniques are feasible and will adequately satisfy the project objectives. From all of us here in Modern Cost Engineering, thank you.